Previously, I've done web development at a couple little startups, and I had my own embedded hardware startup for a while that got acquired, so this is what I like doing. Also, I work out of the Ann Arbor office of Barracuda Networks, so being here at OSU, coming from Ann Arbor, I was kind of torn between wearing a copy shirt and wearing like a big Block M shirt, but the bars last night would have been different had I worn a Block M shirt. Yeah. So, Fuse. It literally stands for file system and user space, which is incredibly clear. Anybody here like writing C? A loaded question in a Python thing. Who likes writing kernel modules? That's what I expected. So Fuse is this cool kernel module that plays a role as an abstraction layer between privileged kernel code and the rest of user space. That's what it's for, and it's been in the kernel itself since 2.6.14, which I think got released on October 28th of 2005, so it's pretty stable. And as we'll see later, you actually use Fuse a lot, whether or not you realize it. So according to Wikipedia, this is how Fuse works, and this is everything you need to know about Fuse. So you've got your kernel, and then you have user space. So your kernel is like the abstraction layer just above your hardware, and user space is where all of your applications live. And Fuse actually lives down here in the kernel, but you can see that it acts as like this dispatcher almost between user space and kernel space, specifically through this thing called libfuse, which is the C library. So Fuse runs on tons of platforms, and since it's a kernel module, here platforms means on kernels. So it runs on the Linux kernel, NetBSD, FreeBSD, OS X, Mac OS X, and there it's called Mac Fuse. Also, according to Wikipedia, it runs on Android, but I don't know what that means, and that's a different argument as to whether or not Android is a kernel or an OS, but I'll put it in here for posterity. And it runs almost anywhere Fuse runs, or some implementation of Fuse will run. So here are some Fuse examples that you probably use, but you don't know that you're using Fuse. The big one is GlusterFS, which is now a Red Hat project. It does like crazy back-end storage stuff. I'm not familiar with it. I've read about it, went, oh, that's cool, and then went on to the next thing. GmailFS is a Python Fuse layer that somebody wrote that uses Google or Gmail attachments as file storage. So you could like mount your Gmail file attachments as a local directory and then peruse them. And more or less your Gmail is infinitely sized. I don't know anyone who's ever hit the limit of what they're allowed to store in Gmail. But that particular instance of GmailFS is very tied to the UI for Gmail. And I don't think it's worked since like the middle of December 2009. And I got the code, which is on Google Code, and it's really out of date, and I wasn't willing to put forth the effort to get it working for today. Also with GmailFS, there's another one called WikipediaFS, which is a Fuse layer written in Python again, where it mounts Wikipedia articles as local files, and you just like edit them in your favorite editor, and when you click save, it goes back up to Wikipedia and is a new revision. Again, that one doesn't work because things like that are incredibly tied to the UI and the APIs that those UIs call. But, I mean, we're all programmers. You can spend a weekend and get something working. GVFS is the GNOME desktop virtual file system. So that's, if you use GNOME, that's when you like double click on a Samba drive or an FTP or SFTP box you have set up. You're actually using Fuse to fake that remote file system as a local one. I guess it also does like WebDAV and SMB. Then this ENCFS, that's an encrypted file system, and it's a fuse layer, but it does transparent encryption of your data. So as far as your local file system is concerned, you just have this directory that has encrypted data in it, but when you mount that encrypted data using ENCFS, all of a sudden you can decrypt it and actually do things with it. Oh, there's Wikipedia FS. But the coolest one, and what this talk is all about, is faking cloud storage as local drives. So it's like Dropbox or Box or the product I work on, copy.com, which is what I'm going to talk about since work's paying for me to be here. Probably ought to talk about work. So there's an important caveat here, is that you can either use their APIs, like published third-party APIs, or if you're willing to muck around in your browser and see what's actually happening, you don't have to. The example here, this copy fuse thing that I'm talking about, we don't use the published third-party API, which is a point of contention, but it is what it is. Somewhere in here I have an example. I'm not sure if it's this slide or the next one. No, it's this one. So the idea here is in Fuse, when you implement your Fuse layer, all you're doing is you are writing a translation between some service and something that looks kind of like a file system to your user space applications. So according to the Fuse documentation, as far as I could tell, the only thing you have to implement that is required is this get attr, which is the file system level static or getting metadata on a particular file. That is the only function that is required by in the documentation. These other ones like read link, make node, make dir, unlink, symlink, rename, link, fs-init, these are optionally you can implement them if they mean something particular to your service. So in the terms of copy, so this is a cloud-based backup storage engine that does all the file syncing and sharing. And it has a nice web UI and a nice Android app, iOS app, desktop things. But in reality, it's just like a big back-end cloud storage. So when a get attribute, when I want to stat a file in my copy directory, what it means is, as far as copy is concerned, I have to issue a request and say, hey, I want all the metadata you have on that file that lives at copy.com/Zachwick, whatever, blah, blah, blah. And what does symlink mean to a cloud service? What does a rename mean? For a file system, I'm just moving some object to a new location in my file system. But for a cloud service, I'm actually issuing a REST call. And these all fall under your file system class methods. And then you have the file class. So these are these functions operate on individual files. On the previous slide, these operate on your file system as a general entity. And then you have your file class, which is to open a file, create a new file, read a file, write a file. Well, you can read them there. Truncate, flush, release, fsync. All right, now the Contrite example. So there's this. If you download the Python Fuse binding package, there is an example in there called hello.py. And it's about the most simple Fuse layer in Python you will ever see. I think officially it looks like it only implements 4 file system operations. So this beginning import is just to make it work when you don't have fuse.py installed. And now the whole meat of it is starts right here. So here I have the class myStat, which this is what we talked about in the file class methods. Here I'm only implementing the get attribute or the stat method for files. That's the only thing I can do in my file system here. And we can see that when I try to stat a file using this hello pi fuse layer, I'm going to get, that, my A time and M time and C time are all 0. My GID, UID are all 0. I mean, like I said, this is a pretty contrite example. And then here, this is, you can see, it's cleverly named hello FS. And this tells us, hey, look, I'm extending the fuse class, and I'm going to do file system level things. And here, we say, okay, look, when the file system wants to do a get attr, you're really going to do this thing called mystat, where you're going to call this, instantiate a mystat object and do its thing. So you can see here that I've got my get attr function, which I need in order to implement my fuse layer. But then chances are I want to be able to do an ls in my terminal and see what's in my file system. So that's where readdir comes in. And again, you can pretty clearly see that all I'm doing is, hey, look, anything that's here, just print it out using some handy fuse bindings. I probably want to open a file. And so here you can see that these are like very C-looking error things. So I'm sorry that it's not very Pythonic, but I guess that's what you get when you're using a extremely low-level C library. Although I'm sure C people have issues with even these naming conventions, as they do with most things. And then you also might want to read a file. So here is what reading a file means to hello.py. And then I just do my using of it. So if we flip over here, I'm sorry, I did not get to the right place apparently. Oh, look. So here's the first point of fuse. So it's not good enough to just have a little Python script and, whoopee, I can run it. What you need is you need to have a real point in your file system at which you can mount your fuse instance to. So that's what it's saying here is, I'm missing a mount point parameter, which is a rather helpful error message. So I'll just make a directory called fuse mount. And now here, woohoo! Oh, more errors. Oh, so I am. It's actually rather hard to read at an angle like this and type. Oh, thank you. Cool, so it worked. And now, if I look to the right, I bet that if I, woohoo! So we all saw that I tried to create this fuse mount directory a couple times, and then I never put anything in it. And now all of a sudden, when I ls this fuse mount directory, I have something in it. And I can open this file, or read, open the file with my implementation from over here. So I'm going to, by just doing a cat on that fuse mount hello, first my file system is going to try to open the file, and then the fuse module is going to kick in and dump me here, and then it's going to try to read the file, and the fuse module is going to kick in and push me here. So, woohoo! It's meaningful text and no error messages. So now this is all well and good, but I still have this fuse thing that's running, and it has this faked file system mounted here. And in order to get rid of it, there's this nice little tool, fuser mount, and then the switch U is to unmount. And now if I do an ls of fuse mount, I have nothing. So I've unmounted my fuse directory. It's a pretty straightforward example. And yes?
Do you mount as well?
I'm sure you probably could. I guess the issue there would be permissions. Because fuse is all user space, note that here I'm using ZSH as my shell, but I did not have to sudo anything here. Sometimes with mount and umount, you might have to sudo. This fuser mount comes with libfuse and any fuse implementation. Cool. So here we only saw 4 file system operations, and we did see that I was subclassing fuse.fuse. And remember how we talked about there's a difference between the file class and the file system class? And in this example, they're clearly separated. I have this hello fs, which is my file system class, and here I have my file class. You don't need to do that. You don't need to have that distinction in your code, but it definitely makes it easier. As we'll see with this copy fuse, they are not separated, and it's kind of ugly, and just ugly. So copy.com. I mean, really, another cloud storage thing, let's face it. But it is cool, and it does a lot of things that other desktop or file syncing services don't do. Copy will, when you're trying to sync data down, it will look at anyone on the same LAN as you that already has parts of those files, and it will, instead of grabbing those parts from the cloud, it will grab them from your peers on your LAN. And there's like a registered port and all that stuff, so lots of bureaucracy, but it's really cool. I mean, we get like everyone in the office, syncing some text document or some notes from a meeting, and it's nearly instantaneous instead of like, oh, I've got to download this giant PDF or whatever. And so we have desktop apps for Windows, OS X, and Linux, GNU Linux, but as you may have guessed here, I'm not like, this is my normal work environment. There's not a real place anywhere for tray icons. So personally, I can't use the GNU Linux app because it expects a place to put tray icons. And there is a command line utility also, but at the time that I started working on this copy thing, the command line did not have the feature set I wanted. So when this copy fuse thing came around, it's like, hey, this is right up my alley, because I can run fuse. And, so I work on the web app for this. And Friday, I put in a commit so that if you go to that link right there, copy.com/PyOhio, you get a bonus 10 gigs. Woohoo! So that's like on top of your normal 15 you get. We've got a pretty good referral program. It doesn't top out like others. I think we have people who are up to over terabytes of free storage space. And this is my favorite picture ever. I have no idea who these guys are, but I know that they are SkyDrive employees at TechCrunch Disrupt, and if you see, they're holding these beautiful copy shirts. I did see that some like Microsoft VIP of Cloud something was giving a talk. I was kind of hoping he was going to be in the audience and he could be outraged at this, but oh well. So, copy fuse. This is... oh well. He said he went out to lunch, so maybe that's for the best. So we have copy fuse, and it's up on GitHub. Pull requests are encouraged. I will personally dole out bonuses for people who submit pull requests. And it runs anywhere that can run fuse and Python, which is everywhere almost. And it will run on a Raspberry Pi, which is the super cool part. So personally, my home media server is a Raspberry Pi plugged in behind my TV, running copy fuse, and then in my copy account, I have movies and all my music, and my brothers have shared these music folders and this movies folder with me, so they're like terabytes and terabytes, but the Raspberry Pi just chugs right along, and oh look, I'll peruse every single episode of Simpsons ever. And it's great. So, because Copy is a cloud storage platform, you get this real-time data interaction. So you can run the fuse layer on one machine, or on more than one machine, and every machine will see the same back end. So it's like an NFS drive, right? But the cool part is, it's all code you can work on yourself, and you can see how it works, and you can play with it, and you can do cool things with it. So after I do these cool demos, then we'll actually look at the code. So we come back here. All right, so you are all going to pretend that you don't see my password when I type it in here in a second. Again, pull requests are welcome. I tried doing this once without taking command line arguments right off the bat, and I was not successful. So maybe someone who's a little bit more well-versed can do it. So here I'm passing in my username, my password, and then just like before, I need a mount point. So.
How concerned are you about this password being recorded in class one?
Not real concerned at all. I already asked them to, make this account its own thing that's, all right, so we're good. And I'll change it a couple times, I'm sure. So I've added some logging to the code base, including logging with a typo, and we can see that I made a request to auth user, I got successfully authed against the copy backend, and I have an auth token. It's probably important to note here that, remember how I said you don't have to use APIs? This is not using the public API. This is hacked together because working on the web app and then just being able to look at the code, one of my coworkers figured out exactly what he needed to do in order to bypass the API but still get all the functionality. So if over here on the right screen, we'll see a bunch of logging as I do things. So I'm in the parent directory of my mount point, and when I do an ls here, you can see exactly what functions are getting called by my file system locally that are getting redirected by the fuse layer. So when I did an ls, and I ended up with this copy fuse point here, I invariably do a get attr. So now I can cd into copy fuse. Oh, and look at all these things it's doing. It's issuing a request to a copy API endpoint. It's doing some other requests, and I must have a Git directory in here, or a Git project in here.
One of your Z shell things.
Oh, good point. Yes. All right, so now here, so all this has done is just, I've CD'd to that, and I have some metadata about where I am right now. And if I do an ls, oh look, I have all of these things. I guess I probably should have showed you that this was an empty directory at first. But now, so a caveat here, and maybe not a point of warning, is if you are making a fuse layer for a cloud backup solution, you are going to get network latency issues. So while this website's coming up, so what I mean by that is it does take a little bit for the API requests to go in or to be issued, be processed, and a response come back. So you can get these disjoint times when it looks like I have a file locally, but it doesn't yet exist in the cloud. And that time span is going to be entirely dependent on your network connection. So we can see that here, I see everything in my copy account over here on the right. And when I come back here, it's the exact same stuff. We'll go into this PyOhio directory. See, this is what I was talking about. So I just hit tab because I'm so used to like typing the first couple letters and hitting tab. And did you see that it had to issue a request over there to list objects to figure out what would be the logical completion when I hit tab? So it does at some point become somewhat of a pain, but well, now when I do an ls here, you see I have some pictures and a tar archive and a song, and in here I have the exact same stuff. All right, so this is like whoopee. You're showing me the same thing two different ways. That's not terribly exciting at all. This is where Fuse gets cool. So let's say I want to upload a directory of comics. We saw that when I did an ls. Browser uploads are a terrible, terrible thing, and every browser implements them differently. This particular browser I'm using, you cannot do an upload of a folder. So I don't really want to like upload, make a new directory called comics and then upload each thing individually. But I have this fancy tarball of, so here you can see comics and then comics.tar.gzip. And I can move this pretty easily into copy Fuse. We'll put it in PyOhio. And here again, we see I hit tab, and there's some latency. Cool. And now it's going to town, syncing it. And you can see all this message over here. And you can actually see what your file system is doing. So it's flushing, it's making a request, and then it's releasing. And those are all file system operations that are implemented in our Python Fuse layer.
It'd be interesting to see rsync the comics directory into your copy Fuse PyOhio 2013. And then you're really doing the recursive directory stuff.
Yeah.
That your GUI web stuff won't touch.
So the comment was, it would be interesting to see rsyncing my comics directory into my PyOhio, where that folder in copy Fuse PyOhio, because then I would get the full recursive moving of the files. And we can play around with that later if there's time. I'm all for breaking things. So the point here is, oh look, now I have this thing called comics.tar.gzip. Sweet, my stuff is there, but I can't like unzip this in the web and see my comics. But I can unzip on the command line. So over here, I see my comics.tar. And here, this is the real-life example of network latency. XV, what do I want here? ZF. All right, so this, if you think about how untarring an archive works, whoa, it's going. No, it's slowly going. Oh, okay, no. So what's happening is, see, my last request is, it's making a request to download the object. So none of these objects actually exist on my file system when I'm over here. So when I try to enact a command on one of them, it first has to get that file from the cloud and real quick get it on my local system where I can use it. And so hopefully my network connection has not died. I'm not quite sure. So the way that the copy objects work is we do some versioning, but copy uses the same backend storage as all the other Barracuda appliances, and so that deals on a file part by file part basis. And we'll see in the code there's some like ugly partify and unpartify functions.
So the backend really doesn't support read semantics.
I don't know if I'm the right person to answer that. The comment was asking why this particular request is doing a full file download instead of a sequential read. And my response is that I don't know offhand why. Also, let's be aware that this only works because we are absolutely abusing the copy API right now. Like, this is incredibly undocumented. This works because people were able to look at the code. And we can see that it finally finished downloading, and I got all my stuff. So everything should be right in the world. If I do an ls on comics, oh, but it's empty. Wait, what? I just untarred it, and I assure you it had things in it. The issue here is the way untarring an archive works. The parent directory didn't yet exist when it tried to... it's this network latency issue. So if I untar again, hopefully it goes a lot faster. Again, we see that it's doing a full file download. So we can move on, and we'll come back and we'll see it actually do what I'm assuring you it can do. Oh yeah, that was my point. Ignore the scary warnings. Like, trust your code that it's probably doing what you want it to do, especially when abusing APIs. I mean, you are already off the farm. Just stay with it. All right. So if you want to implement your own, and you don't want to use copy and use copy-fuse as a starting point, there is a boxfs already, which is available on Google Code, but that's written in C, not Python. So have at it. And I don't know if there's a Dropbox Python layer. I try to avoid Googling Dropbox at work. Gets you frowny faces. But the main point is all you're doing is you're translating real file system operations to what that file system operation means to a different service. I mean, that's what Fuse does. That's why you can mount WebDAV and Samba drives using Fuse, because it's just this translation layer. And you only have to implement the operations that you really care about. You can null op the rest. If you remember in that hello Pi Contrite example, we only did 4 of the possible, I don't know how many actual possible file operations there are, but we only did 4 of them. That's great. That's all we need. In CopyFuse, we do a fair amount of them, but there is a whole section of null opt ones. And realistically, anything can be a Fuse layer data source. You can do microblog posts. Well, we saw that there was like a Gmail file attachment, a Wikipedia articles, a different file system. The way exFAT works is it's actually a Fuse layer, and that's how you can do the extended attributes in FAT file systems, the FAT. It's all implemented in Fuse, which is kind of cool. And, well, these are links to the Gmail FS, ENCFS, the boxfs, and this FuseZip one is you can use a Fuse layer to read and write and unarchive at will zip files, which is kind of neat. Just for completeness, we'll come back here, and I have stuff in my comics directory now. And we can look at these things and all laugh at C. Maybe. If the copy thumbnailer has caught up to me abusing it. Maybe it hasn't. Well, okay, well we can look at it here. So recall that this C joke file does not exist locally. So we'll see I'm issuing a request to download it, and once it's downloaded, ImageMagick will take over and I'll see it on my screen. And we can all have a good chuckle. Oh. XKCD is always appropriate. Yes. I thought there was another joke in here about Python and mutable types, but I must have lost it this morning. So any questions? Yes.
It's interesting. I'm going to go pull it. You said that you avoided the API. It sounds like this is sort of a ex cathedra project.
Yeah.
Not part of the copy suite, just you playing around with it.
Yes. So the
why?
Okay. So the question was, why are we abusing the API here instead of using the real API? That's a two-part answer. So our real third-party REST API just got released and finalized at that TechCrunch Disrupt, and And even now, it's stable, and we actually have third-party devs using it, which is cool, and we are using it internally for things. But if you look at the history of these Git commits, they start a long time ago. And yes, and copy itself started as a skunkworks thing inside of Barracuda. And this is like a skunkworks inside of a skunkworks. And it ruffled feathers that I wanted to talk about this because other people other than me try to not push customers towards it, and I try to push customers towards it because it's really freaking cool.
So it might see productization at some point.
Yes. So in the desktop agents, that you can install on OS X, Mac, GNU Linux, those guys are actively working on implementing a fuse layer in C that talks to the real API. So you can open up preferences and say, mount my copy directory as a local thing, and it does it. And that's, I did see that a dev version came out last week with that feature. So it will be out soon. Any other questions? Yes. The question was, do I expect this copy fuse to be superseded? No, because I'm willing to keep putting time into it. I'm a pretty big free software ideologue, and I really like the ability, or that I have the ability to go in here and just hack away and do something, and I'm not going to get that with the distributed binary. But that's more of a personal issue. Any other questions? Probably went really fast.
I wouldn't violate the TOS.
I'm sorry, what?
I wouldn't be violating copy TOS by using this.
No. The question was, would he be violating the copy terms of service by using this? The answer is probably legally yes. Let's face it. Let's face it. I used an XKCD comic and just said, oh, hey, look, nowhere in here did I tell you it's from XKCD. So I'm already violating the terms of service. But we're not proactive about, and that's probably also not a good thing to say, but you know what I'm getting at here. Yeah, it probably falls under fair use, and I'm not a lawyer, other Barracuda people aren't lawyers, yada, yada, yada. Exactly. No one's going to actively pursue you for using this. Yeah. Other questions? Oh, sure. So this is my information. I have a GitHub, but I really get some sick pleasure out of directing people to a .xxx URL. So if you can figure out how to type in a Unicode warning sign, you'll find my GitHub. Otherwise, you have to go to zachwick.xxx/public, and I have a lot of projects on there. I have a Twitter, rarely use it. Email's probably the best way to get a hold of me. The question was, how much was the XXX domain? I think it's $10 a year. Namecheap was having some sale. I was like, yes, I want this thing. How cool would it be to sending emails, dear grandma, look at my new site, zachwick.xxx. Like I said, I get some sick pleasure out of it, I guess. I'm not going to repeat that comment. At some point, presumably my grandmother will watch this talk, or at least pretend she did. Yes. All right, so let's break some stuff. I guess this is, unless people have other questions, this is probably where the talk officially ends. Oh, thanks for coming, and have at it.